Hey guys, what is up? It's Ewan here, and today we are going to be making our own example or custom node for the shader graph. Now, at the moment I haven't seen any tutorials really on how to do this, and there's also not that much documentation on how to do this. So yeah, right now I'm using the lightweight rendering pipeline as always, and so straight away I'm just gonna create my own shader. I'm gonna call it ES for example shader. I'm gonna right click it and create a material based on that, and then I'm gonna make a cube. Let's see, there we are. Just drag this material on. Alright, there we go. Nice and simple. Okay, next I'm going to create a C# script. I'm going to call it example node. Here we are. I'm going to drag this over for you guys. Okay, so first things first is we're going to need to do using Unity editor.shadergraph. Next, we're going to have this be a subclass of the code function node, and we're going to declare its title. Now, this is sort of like a hierarchy system. So if you put in just the name, then the name will show up first of all when you right click in the shader graph. If you do custom comma and then example node, then it will show up in a subfolder of custom, which will be created for you, and you can do that, as far as I know, continuously. So you could have like custom nodes, math, custom nodes, procedural, and have your own stuff in there. So let's right click on example node and implement the abstract methods. Let's delete the start and update functions as well. Now let's go here and make ourselves a constructor. And what we're simply going to do here is make the name of our node and make sure to have it the same as the node up here, or the name of the node up here. Alright, now that you've got that done, let's go to the protected override method that you just generated and delete everything there. And we're going to return a getType get method. So what we're doing here is we're returning the method which contains the code of the shader. So we're going to do get method, so the name of the method, I'm going to call it the example node method, and then we can add binding flags, so whether or not it's a static, whether or not it's public method or non-public, or whatever you want to do. So I'm going to have a couple of here. I'm going to have a static, and you add an or symbol to add more, so I'm going to have a non-public as well. So that will just grab the method. Now make sure that this is the name of the method that you're using. So let's go for static string, because I've said that it's a private and it's a static method, and I've said it's going to be called example node method. And let's do this. Now here is where we're going to do the inputs and outputs of the node. So what you need to do is slot. You need to say which number it is. So for this one it's 0. And then we need to do binding dot. Now this can you're binding the input to a certain type of thing, whether it's a world space position or a mesh, UV, whatever. I personally am going to leave it for none, and then I'm going to have a dynamic dimensional vector. I'm going to call it A. Oops. Okay, this goes outside the square bracket. So dynamic dimensional vector, I'm going to call it A. I'm going to have another one of these. So what these are is it can be a vector between a vector 1 and a vector 4. A vector 1 is essentially just a float. That's what you call it in code. So if you want to have a float in, it's just vector 1. Let's go for B, and then we're gonna have one more. So this will be slot 2, and this is gonna be the result. So you need to put out here, and again, call it whatever you want. Now, one thing that I have found is that oftentimes if you want to specify, let's say you want a vector 3, you do return whatever, you're going to get an error because you have to the out parameter C must be assigned before the control leaves the current method. Basically what that means is that you need to make the out parameter equal to something. So the easiest way to do that is C equals vector 3.0, and that'll get rid of the error. And since the code really doesn't matter here, it's what's in the return string that matters, then this won't affect your method at all. It's just to stop C# from shouting at you. But I'm going for a dynamic dimensional vector, and that doesn't tend to happen with them. So first off, I'm going to put an @ in front of the inverted commas or speech marks. That is because an @ makes it a multi-line string in C#. So I'm going to format this a little, make it look a little bit nice. So we need open and close brackets. That's very important. I've had quite a lot of issues when writing custom nodes because I just forgot the brackets here. And I think at the moment we're going to keep this to a nice simple method. I'm going to have this an addition method, so C is going to equal A plus B. Nice and simple. So let's go back to Unity. Let's open up our shader. I think we have a warning here. Yeah, this is nothing to worry about. So create, you see here custom, and then example node. Then we got an error. Yes, I forgot to add a semicolon. And now everything should recompile and look good. I'll just clear the errors here. Alright, so quite simple. Let's create a, I don't know, let's have two colors in here. So as you can see, it's able to take multi-dimensional vectors because of the dynamic vector that we had put in. So we can, let's change the color of this. We can make it like an orangey color, maybe a yellow. Let's just pump this out to albedo. Save asset. And there we go. We got a yellow cube. Now, one thing I have found is that oftentimes you can't do much in here. You want to use methods and recursion and all that sort of good stuff, and you can't simply put the methods in here. You need to put them elsewhere. So, seeing how we can't simply put it here, I'm going to show you how to do it. Now, this hasn't been gone over in any documentation and stuff. The only real way that you could find this out is reading the source code. So, let's do public override void generate node function and just leave it like that. Now we're going to have to generate our own custom node function. So I'm going to do registry dot provide function. I'm going to name the function. I'm just going to call it example add. And then we need to provide a string of a string builder for with the string in it. So it's s equals greater than, or yeah, greater than s dot append. So s and then the arrow like thing and brackets. And there we go. And it's in here. We put the function that we want to add. So let's go with float. Now you need to make sure that the function is called the same thing that you named it up here. So I'm going to call it example add. I'm going to have a float a and a float b. And I'm going to have it simply return a plus b. There we go. And now here, instead of the a plus b, we're going to have example add a b. And there we are. Now, in this one, you don't need the brackets like you do here. You can just leave the function in there itself. So let's go down here. Let's open up the shader graph to make sure that there's no errors. And nope, there is no errors. And that's because that's how it works. Turn it around. Let's save this. For some reason though, it does interfere with the color, but as you can see, the function still works roughly as intended. Let's change the red. Make it more of a yellow. So it changes the color now between a grayish color, but that's how it works. You simply add it together to make it more so like to make it so it's not using the first thing. So what's happening here is it's using the first value, so we're getting a value between 0 and 1 essentially when we're adding this, so it's a grayscale value that we're getting back. But if we were, for instance, to make this yeah, I think it's float 3. I think it's a float 3 that they call it in this shader language. We'll find out. There's no error, so it is, but that's not quite right. Maybe float 4 is what we're looking for. Let's add the 4 floats together. Anyway, the point is the same. That is how you add your own functions that you don't want to have in here or can't have in here. Now, the source code is really the best place to look at it. There's it's some documentation with the source code which can help you figure out some things, but a lot of it is just trial and error. So I'll have in the description a link to the source code of the Unity shader graph, because it's in the notes there that the source is. For example, I should bring you across the gradient noise source. So here is the source for the gradient noise in the function. But yes, thank you guys for watching. Please like, comment, subscribe, all that good stuff. Next time, hopefully, I will have a tutorial simply on vertex manipulation and not using its mixed with a water shader or whatever else. So thank you guys for watching. I'll see you guys next time, and goodbye.